Hello guys! Welcome sa ating z-knowledgeTV.
Okay, so natapos na natin yung discussion natin about indeterminate na 0 over 0 at infinite over infinite. So sa video na ito, we will discuss another type ng indeterminate form, which is yung 0 times infinite. So ang halimbawa ng indeterminate form na to ay itong equation na ito, na kung saan kapag dinirect substitute natin yung 0 sa mga x's natin, so lalabas dyan is 0 multiplied by infinite. Okay? So, paano ba natin nakuha yan? So, di ba pag sinubstitute natin yung 0 dun sa x dito kay sin, so magiging sin 0 yan. Kasi 2 times 0 is also 0. So, sin 0 is 0. Okay? And then, yung cotangent 5x is, ang equivalent pa niyan is 1 over tangent 5x. Kasi ang cotangent is reciprocal ng tangent. Tama? So, therefore, 1 over tangent 0, then yung tangent 0 is equal to 0, then 1 over 0 is infinite. So, since na multiplied silang dalawa, okay, so 0 times infinite. So, kaya siya tinawag na 0 times infinite. Okay? And then, since na ang nakuha natin is indeterminate form, okay, so ang isang mabilis na paraan para ma-determine natin yung true value ng ating limits is sa pamamagitan ng L'Hopital's rule. Okay? So, in this video, pag-aaralan natin ang paggamit pa ng L'Hopital's rule, okay, sa indeterminate form na 0 times infinite. Okay?
So, lahat ng ito ay pag-aaralan natin dito sa ating tutorial. Pero, before tayo mag-start, don't forget to like this video and click the subscribe button para ma-notify kayo sa mga next videos. So, let's get started.
So, next. So, ito yung mga types pa ng indeterminate forms. So, napag-aralan natin ng 0 over 0, infinite over infinite. So, kaya kung nais nyo pang malaman o hindi nyo pa napapanood itong dalawang indeterminate form natin, so, puntahan nyo lang yung ating channel. Okay, then search nyo lang itong 0 over 0 at infinite over infinite. Okay, so, ngayon sa ating video, so, ang pag-aaralan natin is 0 times infinite. Then, sa ating mga next videos, pag-aaralan natin ng infinite minus infinite, 0 raised to 0, infinite raised to 0, at 1 raised to infinite. Okay? So, ngayon, pag-aaralan natin ng 0 times infinite. Okay. So, sa type 0 times infinite, so, let's take a look sa example na to. So, para mas mabilis nating ma-gets o maintindihan yung paggamit ng L'Hopital's kapag 0 times infinite tayo. Okay? So, let's say itong example na to. So, kapag sinubstitute natin directly itong value ng x natin, which is infinite, dito sa mga x's natin, so, itong x is infinite na yan. Multiplied by e raised to 2 times infinite. Okay? So, itong infinite as is, so infinite pa rin yan. So, multiplied by itong, since na negative to, okay? So, pwede natin siyang i-write ng 1 over e raised to 2 infinite. Okay? Then, kapag ni-write pa natin, so infinite multiplied by itong 2 times infinite is also infinite pa rin yan. Tama? Kasi napakalaking number ng infinite. And then, itong 1 over infinite, so since ng e, may value yan, which is ang value ng e ay 2.718. Okay, since na numerical siya, so kapag ni-raise mo yan sa infinite, so infinite yan. Okay? Kaya naman, ang e raised to infinite is infinite. Okay? And then, kapag sinimplify natin itong 1 over infinite, since ng infinite, dinivide mo sa 1, so that will become 0. So, kaya naman, ang makuha natin is infinite multiplied by 0. So, kapag ganyan nakuha natin, so dito natin magagamit yung L'Hopital's rule. Okay? So, sa L'Hopital's, so isulat mo natin yung given natin. Okay? So, we can rewrite this equation sa katulad ng ginawa natin dito. So, multiplied by 1 over e raised to 2x. Okay? So, lalabas, ganito na yung magiging itsura niya. Tama? So, ibig sabihin, magagamit na natin si L'Hopital's. Kasi si L'Hopital's, diniderivative niya yung numerator at diniderivative niya rin yung denominator. Okay? So, therefore, ang derivative ng x is 1. And then, ang derivative ng e raised to 2x, so yung 2, baba mo lang. So, magiging 2, e, tapos as is pa rin tong exponent mo. So, 2x. Okay? So, saka mo lagyan ng limits ng x approaches to infinity. Okay? So, therefore, kapag substitute natin yung infinite yung sa x natin, so, mangyayari is 2 raised to 2 times e raised to 2 times infinite. And then, itong 2 times infinite is still infinite. Okay? And then, yes, ulat natin. So, ganyan matitira. And then, ang 2 times e raised to infinite. So, itong e raised to infinite is infinite. Okay? And then, ang 2, pag minultiply mo sa infinite, infinite yan. So, therefore, kapag ganito na lumabas na equation natin, okay? So, ang napakalaking number, i-divide mo sa maliit o sobrang liit na number, so that will become 0 kasi approaching yan sa 0. Kasi hindi naman natin alam kung ano yung pinaka-exact value ng infinite natin. We never determined it. Okay? Kaya nga siya undefined. Yung infinite. Indeterminate. Okay? So, ang sagot natin para kay limit na x times e raised to negative 2x as x approaches to infinite. So, ang sagot natin dyan ay 0. So, next. Paano naman kapag ganito yung equation natin? So, kapag dinirect substitute natin ng 0 dito sa mga x's natin, so, mangyayari dyan, yung ganito itsura. So, 2 times 0. Then, multiplied by cotangent, 5 times 0. Okay? And then, kapag nirate natin to, so 2 times 0 is 0. So, magiging sine 0. Okay? Then, itong cotangent, so, di ba ang equivalent ng cotangent is reciprocal ng tangent. So, magiging tan, tapos 5 times 0 is 0. Okay? So, lalabas dyan, magiging sine 0 over tan. Pwedeng ganyan yung isulat. Okay? So, pwede rin naman ganito na lang. Okay? And then, ang sine 0 is 0. Tama? Then, ang 1 over tan 0, so since na ang tan 0 is equivalent to 0, then 1 over 0 is infinite. So therefore, ang equivalent natin is 0 times infinite. Okay, so since na ganito ang nakuha natin na sagot kapag dinirect substitute natin ang 0 sa mga value na x's natin, so doon na papasok si L'Hopital's rule. Okay, so using L'Hopital, so re-rate mo natin ang ating equation. Okay, so itong cotangent, i-rate natin siya as 1 over tangent. So, magiging tan 2x over, multiplied na muna natin ng 1 over tan 5x. Okay? So, saka natin sila pagsamahin. So, sin 2x over tan 5x. Okay? Then, using L'Hopital's rule, ibaba na muna natin. Okay, so, using L'Hopital's, so, derivative natin ng numerator and then derivative natin ng denominator. So, derivative ng sin 2x is cosine. Okay? Kasi ang derivative ng sine is cosine. So, cosine 2x. Pero hindi pa yun nagtatapos dyan kasi i-derivative pa natin yung 2x mismo. So, multiplied by derivative ng 2x is 2 over derivative ng tangent ay secant squared. Okay? So, secant squared, tapos copy lang natin yung 5x o yung angle niya. And then, derivative ng angle, which is ang angle natin is 5x. So, 5 lang yan. Okay? And then, saka natin substitute yung, o ilagay yung limit natin. So, limit ng x approaches to 0, tapos sin 2x, cotangent 5x. So, substitute natin ng 0 dito sa mga given natin na x's. So, mangyayari, cosine 2 multiplied by 0 multiplied by 2 over secant squared 5 multiplied by 0 multiplied by 5. Okay? So, 2 times 0 is 0. And cosine 0 is 1. Tama? So, therefore, kung 1 yan, so, magiging 1 multiplied by 2 over, then, yung 5 times 0 is 0. Okay? 0 yan. And then, yung secant squared 0, equivalent yan ng 1. So, bakit? Kasi, di ba ang secant squared, x, let's say x mo lang gamit natin. So, equivalent yan ng 1 over cosine squared x. So, since na yung cosine squared x natin is 0, okay? Since na yung cosine squared x natin ay equivalent to 1, kasi ang 5 times 0 is 0, so cosine squared 0, so equivalent yan ng 1. And then 1 divided by 1 is 1. So kaya naman, itong secant squared 5 times 0 natin, o secant squared 0 natin, equivalent yan ng 1. Therefore, 1 din yan, multiplied by 5. So, as we simplify, 1 times 2 over 1 times 5 is 2 over 5. So therefore, ang sagot natin para kay limit ng sin 2x cotangent 5x as x approaches to 0 is 2/5. Okay? So, next. So, paano mga pag ganito equation natin? So, limit ng 1 minus tangent x multiplied by secant 2x as x approaches to pi over 4. Okay? So, paano kapag dinirect substitute natin itong x natin, which is pi over 4, dun sa values ng x natin, sa given x natin. So, mangyari, ganito siya. So, 1 minus tangent ng pi over 4 multiplied by secant ng 2 multiplied by pi over 4. Okay? So, another form niya, kapag nirate natin yung secant, is ganito. Oops. Minus tan pi over 4. Tapos, secant, reciprocal siya ng cosine 2 multiplied by pi over 4. Okay? So, ang equivalent ng tangent pi over 4, take note, in radian to. Okay? In radian. Okay? So, equivalent ng tangent pi over 4 ay 1. Okay? So, equivalent to ay 1. Okay? So, therefore, 1 minus 1 is 0. So, multiplied by itong cosine 2 multiplied by pi over 4. So, ito, cancel to. Magiging 2, magiging 1. So, matitira is cosine pi over 2. And ang cosine pi over 2 is 0. Okay? So, ang 1 over 0 ay infinite. So, since na nakuha natin na sagot kapag dinirect substitute natin ang x natin na pi over 4 ay 0 times infinite. So, therefore, gagamit tayo ng L'Hopital's rule para ma-determine natin yung true value. Okay? So, therefore, sulat natin yung given natin. Okay? Then, kapag nire-rate natin to sa ibang form, so, pwedeng maging ito ang tsura over cosine 2x. Kasi di ba ang secant 2x is 1 over cosine 2x. Okay? So, therefore, since sa may numerator na tayo at denominator, so, using L'Hopital's, i-derivative natin yung numerator at denominator. So, mangyari, derivative ng 1 minus tangent x, so derivative ng 1 is 0. Minus, derivative ng tangent ay secant squared x. Okay? Over, derivative ng cosine 2x ay negative sine 2x. Kaso, hindi pa dyan nagtatapos. I-derivative pa natin yung loob. So, derivative ng 2x ay 2. Okay? So, ito na yung equation natin. So, i-simplify pa natin. So, 0 minus secant squared x ay negative secant squared x. Over negative 2 sine 2x. Okay? So, negative over negative. So, pwede natin i-cancel yan. And then, perform pa natin. Na x approaches to 5 over 4. Okay? So, kapag substitute natin yan, nandiyan ito itsura. So, secant squared ng pi over 4 over 2 sine 2 pi over 4 okay, and then so simplify natin o perform natin tong second squared pi over 4. So, take note, itong part na to is in radian. Okay? So, therefore, ang second squared ng pi over 4, so, pwede mo namang isulat yan as 1 over cosine squared ng pi over 4 over 2 sine, since na 2 times pi over 4, so cancel natin to. So magiging pi over 2 na lang. So pi over 2. Yan. Okay. So isulat natin siya dito. So 1 over, so ang cosine pi over 4. Okay, so sulat natin. So ito cosine lang. Cosine pi over 4. Equivalent niyan ay square root ng 2 over 2. Okay? And then, since na naka-squared yan, so pag i-squared mo yan. So, squared ng square root ng 2 ay 2 na lang. Over 2 squared ay 4. So, therefore, matitirahan ka ng 1 half. So, therefore, ang cosine squared pi over 4 ay 1 half. Over, ang sine pi over 2 ay equivalent sa 1. Okay? Then, kung 1 yan, so multiply natin sa 2. So, matitira is 2 times 1. Okay? So, therefore, 1 divided by 1 half is 2. Okay? Over 2 times 1 is 2. So, 2 divided by 2 is 1. So, therefore, ang limit daw ng 1 minus tangent x times secant 2x as x approaches to pi over 4 ay 1. So, next. So, may tatawag tayong change of variable. So, sometimes it is more convenient to use transformation suited to the type of functions that will facilitate computation. For example, if a rational fraction involves 1 over x, then differentiating will give the same type of functions for any number of differentiations. So it is convenient to use the transformation z is equal to 1 over x to avoid a repetition of the same type of function. So sinasabi lang nito, kapag nakakuha tayo ng 1 over x o sa given may 1 over x, so pwede mo siyang i-substitute o i-let ng z is equal to 1 over x. So take note, itong z is hindi laging z. So ikaw bahala kung anong gusto mong variable yan. Pwedeng a, b, c, or kung anumang letter ang gusto mo. Okay? So next. So let's take a look sa example na to. So evaluate limit ng ln of x over n root ng x as x approaches to infinite. So, kapag tinirect substitute natin yan, okay, so magyari ln ng infinite over n root ng infinite. Okay, so, ang ln ng infinite ay infinite. Okay, over, kapag in-n-root mo ang napakalaking number, okay, so, ang lalabas dyan, infinite. Or pwede mong sabihin na itong form na to is ganito. Multiplied by 1 over n root ng infinite. So, di ba ang ln ng infinite ay infinite? Multiplied by ang n root ng infinite ay infinite. And then kapag dinivide mo yung infinite sa 1, so it will become 0. So ito papasok pa rin si infinite multiplied by 0 natin. Okay? So therefore, gagamit tayo ng L'Hopital's rule. Okay? So we need nating mag-let. Okay? So, di ba kanina sa change of variable, nililet down natin yung 1 over x para ma-avoid natin yung repetition. So, dito may 1 over x tayo. Okay, so let's see. So, let natin u is equal to n root ng x. Okay? So, mangyayari, i-multiply natin sila ng n. Okay? So, kapag minultiply mo ng n yan, so magiging u raised to n siya equals x na lang. Tama? Kasi, minultiply natin to ng n. Okay? Or raised to n. Okay? So, next. So, next natin gawin is lagyan natin ng ln both sides. So, mangyari, ln ng u raised to n is equal to ln ng x. Okay? So, as we simplify, okay, using properties ng exponent o ng logarithm, so, ito is equivalent po siya ng n ln ng u. Okay? So, equals ln ng x. Okay? So, take note na since na ang x natin is approaching to infinite, so, therefore, ang u rin natin, kasi nga, pinalitan natin ang x ng u, ang u rin natin is approaching to infinite din. So, therefore, we have, so, lahat ng mga nilet natin, ipalit natin dito sa equation natin. So, ang ln of x natin ay ito. Tama? So, sige, sulat natin ng equation natin. Ang ln of x natin ay napalitan na siya ng n ln ng u over ang n root ng x natin is u. Tama? So, ngayon, kapag dinirect natin, substitute yung limit natin o yung value natin ng u, which is infinite, dito sa nakuha natin, okay? So, makakuha tayo dyan ng infinite over infinite. So, bakit? Ang ln ng infinite ay infinite. Multiplied by any number, kasi integer tong n natin, so infinite pa rin kalalabasan. And then, yung u natin is equal to infinite. So, infinite over infinite. So, ibig sabihin, hindi pa rin ito yung sagot natin. Okay, so gagamit tayo ng L'Hopital's rule using itong equation natin. Okay, so since may numerator tayo at denominator, L'Hopital's rule tayo. Derivative ng numerator natin, so itong n, pwede natin siyang ilabas. Okay, so magiging ganito. Di ba ganito siya, limit ng ln ng u over u. So, ito, since na integer to, so ilabas natin siya doon. So, matitira, ang mangyayari ay n limit ng ln u over u as u approaching to infinite. Okay? So, derivative ng ln u ay 1 over u. Over, derivative ng u is 1. So, matitira is 1 over u. Tama? So, saka natin substitute yung infinite natin dito sa u. So, 1 over u, o 1 over infinite na, is equivalent to 0. Kasi, large number, denominated sa maliit na number, is approaching to 0 yun. So, therefore, ang sagot natin is 0. Okay? So, therefore, ito na yung final answer natin para kay limit ng L of x over n root ng x as x approaching to infinity. So, 0. So, next. So, evaluate limit ng x raised to n multiplied by e raised to negative x raised to 1 over n. So, kapag ganyan ang equation natin at direct natin substitute ang infinity, so, ganito mangyayari. X infinite, infinite, so, mali ito. So, infinite raised to n multiplied by e negative infinite 1 over n. So, ang n natin is integer. Okay? So, ang infinite raised to n, so, infinite pa rin yan. Okay? Then ito, pwede natin siyang isulat ng 1 over infinite. Okay? So, ang 1 over infinite ay 0. Then, 0 raised to 1 over n. So, equivalent yan ng 0. Okay? So, therefore, since ang nakuha nating sagot is infinite times 0, so, gagamit tayo ng L'Hopital's rule. Pero, we need munang i-let yung mga given equation natin. Okay? So, let natin. So, let, let's say, t is equal to x 1 over n. Okay? And then, mangyari dyan, multiply natin to ng n. So, mangyari, t raised to n is equal to x na lang. Okay? And then, para magkaroon tayo ng x raised to n, so, i-raise natin sila both side ng n. So, mangyari is t raised to n, naka-raise pa ito ng n, is equal to x raised to n. Or, equivalent na siya ng t raised to n squared. Okay? So, since na yung x natin is approaching to infinity, o infinite, so therefore, yung t rin natin, approaching din dapat yan sa infinite. Okay? So, ngayon, so, if yung t natin is x raised to 1 over n, at yung e raised to t natin is equal to e raised to x 1 over n. Okay? So, ginawa lang natin dyan, ni-raise na natin to. Okay? So, kaya siya naging ganito itsura. So, therefore, yung limit ng x raised to n natin, then ito, binaba natin. So, mangyari is e raised to x 1 over n as x approaching to infinity. So, equivalent yan ng ang x raised to n natin ay t raised to n squared. Tama? Yun. Over, ang e raised to x natin raised to 1 over n is e raised to t. Which is ito naman yan. Okay? So, kapag substitute natin yung x approaching to infinity natin, or syempre t approaching to infinity rin, so, substitute natin sa value ng t natin, so, mangyayari is infinite raised to n squared over e infinite. Okay? So, since na yung n natin is integer, and then, kapag ni-raise mo yun sa 2, okay? So, eto, pwede pa natin siyang masabi na t raised to n lang. Okay? Parang i-assume lang muna natin. Okay? So, kasi, i-squared mo lang naman yan. So, parang pinapalaki mo lang yung value ng n. So, kapag dinerivative mo yan, so, continuous yung derivation mo. Okay? So, masyadong matagal, long computation yan. So, tinatawag natin yun na tedious computation. Okay? So, ibig sabihin, habang diniderivative mo yan, okay, so papunta ka ngayon sa tinatawag natin na constant. Okay? Over, ang e raised to t natin, pag dinerivative mo, is still siya sa e raised to t. Okay? Kaya naman, kapag pinalitan mo tong t ng infinite, so constant sabihin natin, over e raised to infinite, so, ang e raised to infinite ay still infinite yan. So, any number na dinivide mo sa infinite, so ang sagot dyan is 0 kasi approaching sa 0. Kasi yung x natin na approaching to infinite ay papunta na siya sa 0 ang sagot. So, therefore, ang limit natin ng x raised to n multiplied by e raised to negative x raised to 1 over n as x approaching to infinity ay 0. So, next. So, paano naman kung ganito yung ating equation? Limit ng 2x minus pi multiplied by second x as x approaching to pi over 2. So, could you able to answer this? So, if yes, so please comment your answer. Okay? So, dito na nagtatapos ang ating video about indeterminate form na type 0 times infinite. Okay, so sa ating next video, so ang pag-aaralan natin is infinite minus infinite. So, saan natin to pwedeng makita? So, ang example nito ay ganito. So, ang limit ng 1 over x minus 1 over sine x as x approaches to 0. So, kapag dinirect substitute natin ang x natin na 0 dun sa mga x's natin, okay, so 1 over x o 1 over 0 ay infinite. And then, ang sine 0 natin is 0. And then, 1 over 0 is also infinite. So, doon papasok ang infinite minus infinite. So, kapag ganyan na nakuha natin, so gagamit tayo ng tinatawag natin na L'Hopital's rule. Okay? So, para mas maintindihan natin ang concept ng infinite minus infinite at sa paggamit ng L'Hopital's rule, so stay tuned lang tayo sa ating channel. Okay? So, ayun lang. So, maraming salamat.